We still have a little more to do with ellipses, but we'll kind of mix that in with hyperbolas. They're very similar in their equations and how you work them. So, of course, we've talked about circles. We started with that. And then we talked about parabolas. So if you cut the cone at an angle through the bottom of the cone, and that's when you get the parabola. And we talked about that. And of course, you know from Algebra 2 all the quadratic, types of things regarding the parabola as well. And then we talked about if you slice the cone diagonally through there like that, that's the ellipse shape. And then the last one is if you have the double cone, double nap cone or stacked on top, you get, and you slice it straight up and down parallel to the axis, you get the hyperbola. This is just one branch. A hyperbola actually has two branches on it, and we're going to talk about that today. Okay, so reviewing the ellipse part, because things have again somewhat disjointed and so forth, and I don't have decimals in here. There either. Okay, all right, so our horizontal ellipse, the basic equation of that looks like this, right? Now let's review a couple of the main things on the ellipse. Tell me about the A and the B.
The A is always 100%.
A is always bigger than B, right? So A squared is always bigger than B squared. Now some of you on the quiz with parabolas ran into some trouble with the squaring part of their circles. You got x squared plus y squared equals r squared. So that number over there, if that number over there is 10, the radius is square root of 10, right? Or if you want to write x squared plus y squared equals 10 squared, right? That's okay. I mean, normally we would write down 100. But if x squared plus y squared equals 100, the radius is 10, right? The square root of that. Same thing here. The numbers underneath here are the squared version. So if it's 4 and 9, then A would be 3 and the B would be 2 and so forth. So understand when it's squared and when it's not. And then A is the longer, and then those are the lengths. So if in this particular ellipse, it looks like A is 3 right here, and sure enough, from the center, 1, 2, 3, and 1, 2, 3, and that's called the major axis, and that is also where the foci are. Okay, the foci are also going to always be where A is. Okay, the foci are always going to be where A is, and then B in this case is 2. And 1, 2, and we go up there. So you kind of think of those as the radii. That's called your minor axis, okay? So that's where you get those. And then how do we get the foci? C. What's the equation we use for that? A squared minus B squared. Now that's one of the reasons I give you the formula sheet is because of that as well, because it's going to be different, just slightly different for a hyperbola, and so you'll have to try to remember that, but or you won't have to because you'll have the gold sheet. So once we know in this particular problem, 3 squared is 9 and 2 squared is 4, so we know C squared would be 5, so C would be square root of 5, which is about 2.1 or so. You can do that in your head, but you'll have your calculator, so you can look at that as well. So 2.1, so a little past 2, and then a little past 2 is your foci. Your foci are there. Okay, now the way we would write that is we want to write that coordinate as square root of 5 comma 0. And this one we'd want to write negative square root of 5. Let's don't go to decimals with those. Let's leave in terms of radicals. Then we don't get into rounding issues and so forth. Okay, and those are the numbers that we usually are looking for. These are called the vertices, by the way. The A values, the ends of the major axis, are called the vertices. So when it says find the vertices of the ellipse, those are the A values along there. Those are the ends of the major axis. We really have no name for these other than, I guess you could call them the endpoints of the minor axis. If the direction said the endpoints of the minor axis, then that would be those values. But we really don't have a name for those. Okay, but vertices are the endpoints of the major axis. Okay, and then of course, when the bigger number is under the x, that tells you what direction to go with your A, right? And so that's a horizontal ellipse. A vertical ellipse would be when your bigger number here, your A, is underneath the y. So when your bigger number is underneath the y, then we're going up and down 3. And so that would be your vertices, and then your foci would be up and down as well. Okay? So those are kind of the basic things to know about the ellipse. All right, what questions do you want to look at on the homework, if any? Oh, what was the other thing? Eccentricity. What's the equation for eccentricity? C divided by A. Now remember, C and A are on the same line, and C is always shorter than A. So therefore, C divided by A is always going to be less than 1. Since C is smaller than 1, or smaller than A, then that fraction, that decimal, is always going to be less than 1. And so it's always going to be somewhere between 0 and 1. And if you got to watch the video, last night we talked about that. If it's close to 1, that means these two are pretty close to being the same. So an eccentricity that's close to 1 is going to be a pretty elongated ellipse, because the foci are going to be way out here next to the vertices. So C and A will be pretty similar in length, so when you divide them, that'll be pretty close to 1. If it's pretty close to 0, that's when you have a more circular scenario, right? Your foci are in close. C is very small. And when you have a fraction where the top number is very small compared to the bottom number, that's going to be a very small decimal. Going to be close to 0. And we talked about the planets having elliptical orbits, and they're pretty circular. They have a pretty small eccentricity. Okay, and so the planet, and also we talked about how the sun is at a focus of the elliptical orbit, not at the center. Okay, and that's a misconception a lot of people have. They talk about they revolve around the sun, which they do, and they orbit around, the planets orbit around the sun, but the sun is at the focus of the elliptical orbit. Okay? All right. So, anyway, questions? None? Easy? 50? Yes. Did we do 50? Oh, that was on the day before. No. No, I'm sorry. I mean, so we didn't do 50 in class. Why does that look really familiar? Of course, like yesterday, I tried to give you the wrong assignment you'd already done the day before. Hang on a second. Why do I feel like I've got...
You put it on your website.
This, the assignment.
Yeah, it was.
Yeah. Why, okay, this was that was 51, right?
Yeah.
And we did that the other day. 50,
Yeah,
okay.
50 and 51.
Right. Yes, okay. They are kind of similar. All right. So on 50, yes. I mean, let's go through it. It won't hurt anybody to see it. So Jacob, read that one too.
16x squared plus 25y squared minus 32x plus 50y plus 16.
Now you can tell when you look at this problem that it is manipulated to work nice. Okay, I mean, you see the 16, you see the 32, you see the 25, the 50, you know what I mean? And that's what I'm going to give you. Now, if those numbers weren't that nice, you get into kind of fractions and decimals, which you could do, but it's just longer, and you get bogged down in just kind of the arithmetic of it. And so, trying to keep just the main idea here. Okay, so these are somewhat manipulated. That's where a thing like Desmos and our electronic graphing calculators, computers, those kind of things, if we get into really messy stuff like real life orbits and those kind of things, measurements would not work nearly as nice. It'd be the same idea. So now using those things, you wouldn't need to know a lot about it other than how to use the instrument you're using. But obviously to write those programs and to be able to understand them, you would need this knowledge of all this stuff we're talking about. Okay, so anyway, back to this. We put the 16 over on the other side, don't need it. We're going to do what with these numbers here in front, the 16? We're going to factor it out. We said yesterday it's just going to work better if we factor this out. We leave ourselves a blank to complete the square. And here we're going to factor out a 25, and we're going to leave a blank to complete the square. And then, of course, we got our negative 16 over here. And so then we're going to complete that square by adding a 1. But really, what did we just add? We actually just added a 16 times 1, right? And so that's going to go there. Here we're going to add a 1. But we really added a 25, okay? And so we got a 16 and an x minus 1 squared. We've got a 25 and a y plus 1 squared. And then we got what over here? 25, right? So now what we want to do is what? Our first goal is to get a 1 over here, right? Now the one we did, if you watch, again, should watch the video, we did one yesterday where we actually had a 1 over here once we got to this point, right? Once you get a 1 over there, then there's nothing you can do with these numbers that are left, which you're going to see here in a minute. So we have to invert and divide, I guess you might say, and you'll see that in a minute. But since we want a 1 over here, we're going to divide by 25, which means we're going to divide that by 25, and we're going to divide that by 25. Now you notice right away that doesn't simplify, okay? So let me work backwards here. Here's a 1. Those cancel. So when we write it, we're probably going to write y plus 1 squared over 1, because that's how we want it to look. And then what do we do with this? We flip. So what we do is we say, okay, I like the 25 down here. Or maybe we don't even think that. We think what we really have here is we have 16 25ths times x minus 1 squared is really what we have right there. Well, timesing by 16 25ths is the same as dividing by the reciprocal, right? Dividing by 25 16ths. So what we really have here is x minus 1 squared divided by 25 16ths, and that's how we want to write it. So which one of those is bigger? This one, right? So this is our A. So our A, so I don't remember what were the directions here. Write it in standard form and then do all that other stuff. Center and everything. Okay, so let's go ahead and do that. So let's take this. I got way too much stuff. Let's copy that. Let's go to the next page. Okay, paste that in. So we got this. Okay, that. Okay, so we got A is what? 5/4, which is 1.25. You can use a decimal there. I don't mind a decimal on that one. And in this case, B is 1, right? It's a square root of those, right? So make sure we get that part right. Seems like sometimes that's the part we'll mess up, is forgetting that it's the square root. This down here is A squared, and this down here is B squared. And so we got to do the square root of this. Okay, and so where's our center? So now let's go. We had to graph it, right? And that's something we need to do. So where's our center? Now I'm going to go by double march. So 1, negative 1. Okay, so we got center at 1, negative 1. And this ellipse is going to go what? Vertical or horizontal? To be honest, you don't really have to worry about it. All you really have to do is say, okay, my A is 1.25. It's under the X. So that just tells me I'm going to go 1 1/4 from the X. And I'm going to go 1 1/4 from the X, right, along the X. That's really all you have to do. Those are my vertices. That's the endpoints of my major axis. Here I'm going to go 1 along the Y because it's under the Y, and I'm going to go 1 along the Y. So this is a very circular, pretty circular ellipse, right? Pretty circular ellipse. A and B are pretty similar. We got C squared equals, so 25 16ths minus 1, which is what? 25 16ths minus 16 16. You got calculators, I get it, but it's 9 16ths, right? So C would be 3/4 or 0.75. But again, use your calculator for that, that's fine. Okay, 0.75. So here is C, so 0.75, here's 0.5, so 0.75 will be about there. Now again, it is important that you go the right direction, right? You remember that A was under the X, A and C are on the same axis, right? So the fact that this one's horizontal, we got to make sure we're going the right direction. So there's our C right there. And that is 3/4 or 0.75. Okay, so let's start writing some of this down. So our center is 1, -1. Our vertices are what? Yeah, now remember we had one, and if you want to do fractions or decimals, I don't care, but we went from an x of 1 and we added on 9/4, right? So what's 1 plus 9/4? 13/4 or, no, I added 5/4. It's, yeah, 5, not 9/4. 5/4 plus 4/4 is 9/4. 9/4 or 1 3/4, right? So 9/4 or 1 3/4 or 1.75, right? No.
No, you add that to
2, God, jeez. 9/4 is not 1 3/4. 9/4 is 2 1/4, right? Jeez. Well, just, yeah, thank you. It's Wednesday. Okay, 2 point, let's use this. 2 point, because we said it right there, 1.25, right? So 1 plus 1.25 is 2.25, -1, the y value stays the same for all these points. And then the other one, we subtracted 1.25 from 1, so that should be -0.25 or -1/4 and -1. So the y value doesn't change. Our foci. Now a lot of times we have a radical we have to put in here. And what we would do with a radical, let's say this was radical 2 or whatever, we would do 1 plus radical 2. We talked about this yesterday. 1 plus radical 2 and 1 minus radical 2 going that way, right? We would just add that on and subtract. But now we're going to have 1 plus 0.75, so that's going to be 1.75, -1. And then we'll have 1 minus 0.75, so that'd be 0.25 and -1. So again, it just goes from, if you're going horizontally, you add or subtract your x coordinate. If you're going vertically, you add and subtract to the y coordinate. The other coordinate stays the same. Okay, what else did they want? Eccentricity, right. Eccentricity is C, 0.75, divided by A, 1.25, which is, how much? 3/5 or 0.6, either one of those is fine. 3/5 is fine, 0.6 is fine. So it's over a half, it's closer to 1, it's pretty circular, okay? All right, so there you go. Okay, good, answer that. Okay, so again, the big thing is this side, right? This is the main thing. You know, you get partial credit, but this is what's most important. So you're going to lose a lot of points if you can't get through this, right? Now, I will give you, I'm not going to take off all the points. If you get an equation that's wrong, for example, you have a minus sign right here, right? You have a minus sign right here. Well, that's going to throw off your center. It's going to throw off everything, right? Because you're going to have 1, 1 as your center, and so your graph's going to be wrong because it's going to be up here, right? And your vertices are all going to be wrong. But what I'll do is I'll look at it, and I'll look at your calculations, and I'll see if you went from the center, you went the right direction, and you had the right ones with your numbers, and I'll give you some credit for that, right? You'll get some credit for doing it all right from there, you know, just missing that one sign there, okay? But you are going to lose some points, so be careful. All right, and we're going to be especially careful today when we do hyperbolas, because what we're going to find with hyperbolas is there's only one real difference in the equation. And the difference in the equation is one of the squared terms is going to be negative. In other words, there's going to end up being a minus in between here instead of a plus. You can look at your gold sheet and see that. There's going to be a minus here instead of a plus. So when one of the squared terms is positive and one of the squared terms is negative, you know you have a hyperbola every time. Circles and ellipses are connected in the sense that the x and the squared terms are both going to be the same sign. If they're both negative, you can take out a negative, and then they'll both be positive. But if one's positive and one's negative, you can't take out a negative and solve anything, right? And one will still be positive and one will still be negative, right? And that's when you know you have a hyperbola. Okay, so let's go ahead and do that today here. Let's get our notes out and let's go through. And we're just going to, again, get started with kind of the basics today, although it's quite a bit of stuff. But you're going to see a lot of similarities between what we do with the hyperbola and what we do with the ellipse. Okay, but it... All right, so first of all, by definition, a hyperbola is a set of all points, x and y. The difference, and I put that in red because what was the word when we did ellipse? The sum of whose distances was a constant. Now it's the difference of the distances between the 2 points. If you subtract those distances, it's constant for every point on the hyperbola. And remember, x and y in our equation, x and y represent points on the graph. So x and y represents points on the circle, x and y represents points on the parabola, x and y represents points on the ellipse, x and y represent points on the hyperbola. H and k is the center. Now, I don't even have the center in here. The center is not part of the hyperbola, just like the center is not part of the ellipse, just like the center is not part of the circle, right? But it's an important element in the drawing of that curve. So the center is right here. The vertices are right there, like they are on a parabola. And the foci are inside there, just like they are on a parabola. Those are not parabolas, though. They're U-shaped. They look kind of like parabolas, but they're actually not. Okay, and we're gonna talk about that as we draw them. Okay, so that is the definition of a hyperbola. All right. Now on Geometer Sketchpad here. Oh, that's pretty. That's what we're doing. That's what we're doing in calculus today. Kinda. What are those cakes? Like a bunt cake or something? One of those bunt cakes.
It looks like a cage.
Yeah, cage. Kind of like school. All right. All right. So hyperbola. So see the dark blue right here. That is going to remain constant. This dark blue length right here is going to remain constant. So here's our two fixed points, or foci. So we're going to take this distance, take away this distance, is going to leave us the dark blue. And the reason the circle's here is so you know that these two distances here are the same. And so when we subtract those, when we take this distance and subtract off this, it's going to leave us that dark blue. And it's going to stay this length right here. Okay? So as I grab this point and move it around, okay, you can see that this length and this length, so if we take this length here and subtract off that length, that's going to leave us this length, which is that difference. That stayed the same the whole time. And so you end up with this, okay, and if we drag over here, right, so all of those points keep this length a constant, okay? And so we kind of see that going through there, okay? There's the hyperbola right there, okay? And we don't really need the rest of the stuff on here. Okay? Now, when we go, you don't have to write any of this down yet. I'm going to show you this. But when we go to, yeah, it's a lot of stuff, I get.
No.
It's not bad. Okay? Now, so let's look at this hyperbola. Let's talk about the different pieces. Okay, first of all, you got your center. Okay, that's the H and the K. So again, it's very, very similar. And we don't have the equation up here. We'll draw it in a minute. So there's your center. Okay, notice the A value. Okay, now we're going to talk about the A value. The A value is not always going to be the biggest this time. Okay, now remember I said that the square, there's going to be a minus sign in between, right? So the order you write your equation is important. With hyperbolas, with ellipses, we usually wrote the X first and then the Y, just for alphabetical order. But you wouldn't have to. There's a plus sign, so you can switch them around. Wouldn't matter. We just always knew that A was the biggest one, right? So with the ellipse, that's how we could tell which way it was going to go. With a hyperbola, since there's a minus sign, the order you write them is going to be important. So the A is always going to be the first, under the first one. A is always going to be under the first one, and B is under the second one, the one that's subtracted. Okay? So anyway, so if A is under the X, we're going to go this way. If A is under the Y, we're going to go up and down, much like we did before. The only difference is with the ellipse, we know A because it's the bigger one. With hyperbola, we'll know A because it's the first one. Okay? And then B goes this way. Now, when you notice this little box, so what we'll do is when we draw our A and we do our B, we'll make a little box, like so. Then, notice those yellow lines. The yellow lines are called the asymptotes, and we've talked about asymptotes before, of these hyperbolas. And that's why these are not parabolas, okay? Because what the hyperbola does, from A, which is like your vertex, right? We said those were the vertices on the ellipse and the vertices here. This is going to get closer and closer and closer to that yellow line. And this is going to get closer and closer to this yellow line. And the same thing over here. So we'll just sketch in these diagonals through the box. And then we'll just put in our, we might call them parabolas. I accidentally have a little bit. We'll put in our hyperbolas. And we'll just make it so that they get closer and closer. So they get a little straighter here than a parabola would be. A parabola kind of curves up and keeps curving up, right? This one is kind of straightening out. So it's a little bit different shape than a parabola. Okay, and that's really what we do. And now to get the focus, we will use C again. And C will always be on the same line as A. Okay, so it's, again, very much. Now, how do we know whether it wraps this way or up and down? Well, it's wherever the A is. Okay, so whichever one comes first. So if the X comes first, we're going to be, our hyperbolas will be on the X. If the Y comes first, our hyperbolas will be on the Y. Okay, so let's take a look at that. I did that already. Okay, so I'll give you some time to jot this down here. So we can write, well, I don't know how much you need to jot down. You got the gold sheet, right? You got the gold sheet, but maybe you write it. Maybe it helps you to see it if you write it. But so you can see what the equation looks like. We still have our same H and K. So that's your center, okay, which in this case is, an example I gave you here is right at the origin. You notice there's a minus sign in between. We said A will always be first. A might not be the biggest. B might be bigger. Okay, so that's one thing we're going to always have to make sure we keep straight. The focus, C is going to be bigger than A now. C is going to be bigger than A because the focus is outside. Well, it's inside the hyperbola, but it's farther out from the center than A is. C and A will always be on the same line, just like they are with an ellipse. Notice the C squared equation is a little different. It's A squared plus B squared. It's actually like the Pythagorean theorem. Okay. Now that makes sense that C we said is going to be bigger than A, so it makes sense that we'd have A squared plus something for our C squared. Unlike the other one, we had A squared minus B squared, so because C was littler, C was littler than A. So we took A squared and subtracted B squared. Here we take A squared and add B squared. Okay, the vertex is that point. Since this hyperbola equation had the x first, the hyperbola wraps around the x-axis. It's a horizontal. And that's because we went horizontally with our A. We went in the x direction with our A. And the hyperbola is always going to wrap around A and C, the focus. Okay? But drawing in that little box is going to be the key, well, one of the keys, because we draw in that little box, then all we have to do is draw those diagonals through there. And just draw them lightly, dashed lines, you know. And those diagonals are called our asymptotes. Now, up here, another thing you'll be asked, oftentimes, is to write the equations of the asymptotes. Now, they're just lines. They're just lines, okay? And so, it's really quite simple. Y minus K and X minus H, those H and K are your center points. So really, you can take that right off of the top of your equation, right? Now remember, a line is always going to be y minus k on to the left. It's always going to be like a y equals. So y minus k, which you'll already have in your equation, and x minus h, which you'll already have in your equation, go there. And then all we need to put in front is a slope. Now they have the same slope. One of them's a positive slope, one's a negative slope. Now do you see why this would be b over a here? You don't have to memorize this. Well, number one, it's on your gold sheet, so right. But I mean, it makes perfect sense. It's slope is rise over run, right? Look at this line. What's the rise of this line? What's this distance right here? B. What's the run? A. B over A. B over A, right? So, rise over run. So it's easy. Okay, but again, it's on your gold sheet there, so it's a lot to keep track of. But and then you just write it like that. Just leave it like that. Okay. All right. And then vertical. Okay. What changes? Well, you notice on your equation, the y comes first this time. Right? The y comes first. Now, if you don't want to write the whole thing down, it's very similar to what you just wrote on the other one, which is fine. It's on your gold sheet. The y comes first. And it matters because there's a minus sign in between. Okay? So the order matters. A always comes first. This time A is under the y. So this time we're going to go up A, and we're going to go down A. And we're going to figure out our C, and we're going to go up and down. C is always on the same line as A. And that gives you your focus. B is the other one. This time our rise over run as well. For our asymptotes. It's A over B this time, right? This time the line is, the rise is A, and the run is B. A, so this time the slope is A over B. Plus or minus. One's positive, one's negative. Okay. And again, wherever the center is, the lines will always go right through the center. The lines will always go right through the center. So they'll contain that center point, and then they'll contain, then they'll have the slope. It'll be B over A or A. Again, if you're not sure, you can look on the gold sheet, but when you draw your picture, you'll be able to see 3 over 2, 2 over 3, whatever. Because you'll have these numbers. You'll know this right. Okay, so it seems like a lot of stuff. But, okay, all right. So once we have the hang of ellipses, there's a lot of similarities. A lot of similarities. All right, so make yourself a little XY axis here and plot those points and figure out all the different information you can glean. See what all information you can get out of it if you just know that much right there. See how many different things you can figure out. So let me just put a couple things on here. Okay, so right there, when you draw the first two things I gave you, the foci, what's that tell you right away? It's horizontal. Okay, so that means your x is going to come first, right, in your equation. What else does that tell you? The center. Center's got to be halfway in between, right? So that's a distance of 6, so it's got to be 3. So it's got to be right there at 2, 2, right? So that tells you that. And we know the x has to come first. So I'm sure one of the things you would be asking this problem would be to write the equation, right? So look at that. You already have that much of it done. You got the center. You know the x has to come first because it's horizontal, right? And then we go ahead and plot the vertices, 0, 2, and 4, 2, right there. So now I'm not going to draw in my hyperbola yet, okay? But because I want to get the asymptotes and those kind of things. I didn't tell you. I just said, what information do you have? Well, I think the answer to that is you got everything. All the information's there. Everything you need is there, right? And so what else? What else? Where would I go from here? You know A. You know A is, right? A is there. Now, it's different than an ellipse, right? An ellipse, A would be all the way out to here because the foci are inside the ellipse. Here, the foci are outside of this thing. So the foci are here because it's going to wrap around. So you know A is 2, and we know A comes first. So what do I put down here? I'll put a 4 down here. Okay? And what about the Y? The B? Oh, wait, I don't know that. Well, what do I know?
C.
I know C. What is C? C is 3. So I know C squared equals A squared plus B squared, right? I know C squared is A squared plus B squared. So therefore B squared is 5, which is important because that's what I want down there, right? Down here I want B squared, but to draw my picture I need B, and that is square root of 5, which I know is about 2.1 or so, right? And so I'm going to go up about 2.1, and I'm going to go down, which is going to take me just below the axis there. I'm going to go down about 2.1, which is square root of 5, and now I can draw in my box. Right? Like so. Now again, like we said, the A is not always the biggest one. Not a problem. It's the first one. Okay, oh, and we know this is going to equal 1, right? So we got our equation already. We got our equation. Now all we have to do is come in here and draw in our asymptotes, our diagonals, like so. And we know it's going to wrap this way, and we just kind of go out and just get those pretty close to there like that. And oops, don't draw it from the focus. It's going to wrap around the focus. And it's going to come in kind of like that, and that is how you do that. Okay? And so maybe this question would have said to sketch it, maybe, and draw the asymptotes, or write the equation of the asymptotes. So that'd be y minus 2 equals plus or minus, and then here is going to be x minus 2, right? It's just your y minus k, and here's your x minus h, so it's whatever you had here. Now, they're not squared. They're not squared, right? This is a line equation we're doing, so they're not squared. They're first power. But y minus 2 and the x minus 2, and then all we got to put there is either the b over a over b. If you didn't even have the gold sheet, it's still easy to know. What's the rise over run? What's the rise here? How much was this distance right here?
2 point something.
Square root of 5, right? Let's call it square root of 5, right? 2.1. So this was square root of 5 as your rise, and your run was 2. So it's square root of 5 over 2. So it's square root of 5 over 2. You don't need to simplify those or anything. If that was 2 over square root of 5, just leave it. 2 over square root of 5, that's fine. Okay? So again, but you could look at your gold sheet. It was b over a. For that one, it's b over a, so you got it there. But it's easy to see. It just rise over run. Okay? So that's the equation of your asymptotes. Right? So forth. All right. So, there you go. Did all that work. All right. So, we got a little bit of time left. Let's see how we can do this. So now let's do the reverse of that. Let's give you the equation. Now, can you get that into standard form? Okay, can you get that into standard form? Now, it's just like with an ellipse. Do the same thing you do with an ellipse. But you know this is hyperbolic because you see the minus sign. Okay? All right, see how much you can do here.
I've done the first 3.
Well, I don't feel sorry for you if you haven't even done the
I did. I got
because that was those have been up there a long time.
I've spent like literal 40 minutes.
L4 is it's weird, yeah.
On which one?
04. 04 was tough.
I got 04
It
down.
took me a while to get used to it because it's.
All right. Now, let's finish this, and we're going to do one more. Yes, so on the IXLs, next Friday, April 20th, and to be honest, I probably will not get to grading those until during the weekend sometime of that, so if you finish them probably Saturday the 21st, but I might Sunday evenings get to them, or Sunday sometime, so I wouldn't wait till Sunday night, then it might be too late. But I have added, the first two here are ellipses, and the next three are hyperbolas, so it would be good to get those done by the middle of next week sometime for those kind of practice. Tomorrow, I will be gone, and some of you may be gone too, but so that's, sorry, you don't get that work time, so you'll have to find it some other time. But I do have a couple other things we'll be doing, a couple of worksheets that you can work on together, and a problem that you have to try to do, and so you'll spend a little time on that. But I also have in my notes some IXL work. Okay, so the worksheet assignment will be due on Friday, so you might want to get that done first, but I think you would have time probably to spend some time on IXLs during class tomorrow, okay? And then I think there's going to be at least another time in class where we'll get at least some work time. And to be honest, next Friday, I will be gone, and that's Friday, April 20th, so I'll probably build in some time there for some work, okay? So shouldn't be awful unless you're still in the M's. Then you might be in trouble. Okay? All right, so let's finish up what you can on this one. Are we about done with this one? Of course, I didn't really give you any directions, but graph it.
Yeah.
Asymptotes, do we kind of have a lot of it there?
Yeah.
Okay, so what did you get for the A?
2.
The B and the C?
Square root of 20.
Square root of 20, right? And we can leave it at that, which is about 4.5 or so, right? It's somewhere between 16 and 25, as far as perfect square, so somewhere around 4.5. Again, you've got calculators, you can do that as well. Okay, so what I got looks like this. Now I did put the asymptotes up there. I didn't write down. Oh, I do have the foci right here. So C would be square root of 20. Again, this is another X comes first. We divide by 16 because we want to get a 1 over here. Okay, and so it all reduces like so. A is 2, remember A comes first. B is 4. Here's your C, square root of 20. So again, we draw a box, so we go 2 this way because it's under the X. We go 4 up and down because that's the Y. And notice the foci are fairly far out, so it's a pretty kind of flattish hyperbola, right? The farther out the foci is, the flatter it is, kind of like very much like a parabola. And the more thin and skinny it is, the closer in the focus would be. And then the asymptote is the rise over run, so this is 4 over 2. 4 over 2 is 2, or in this case, B over 8 again. Okay, all right, so let's just do, and we won't do the whole thing on this one, but let's go ahead and get the equation of this one. So this is, again, that completing the square stuff that we've been working on, but now you have to be careful with the negative. Now on that y squared, when you take out that 3, you'll be taking out a negative 3, so you've got to be careful there with your sign. But go ahead and try that. We won't sketch the whole thing. We'll just do asymptotes and foci. Shoot. Well, okay, here it is, right? You do this, then you divide, then you got this. Okay, Jack, you with me, Allie? Okay, Caleb, good job. All right, here you go. Da, da, da. Okay, all right, on. So,
Nice.
so if only the videos went like that every time, right? Instead of dragging on. There. All right, there you go. Let's work on those. For tomorrow, well, actually, you'll get probably check them on. Probably, I haven't checked the Sundays before. I need to do it.
No, that's okay.
We can do that on Friday. That's what we'll check on Friday. Make sure you get. Well, also the worksheet that you do tomorrow too, is for Friday. So let you work on those. You guys want to start on the quiz? Let's do that, and then we can just go into break. And so when the bell rings, I'm going to move you over to Mr. Boyer.
I'm still recording.